Let's continue on with the top chord. So the top chord is pretty much going to be the same story. In fact, I think it's just about going to be exactly the same thing. So I'm going to just copy this, paste it, put it down here. And I actually will copy this in case I want to change the top chord thickness to be different than the bottom. So I'll change this to top. And then make sure that you replace the connections. So you won't see this one, that this one is actually connected down here to the bottom chord thickness over here. So you have to override that one manually. So now this one is connected, and make sure that you rename this one as well, just to be clear, so you don't confuse yourself. You have to rename it in both positions. So change this to top. And then you also have your bottom curve plugged in down here still. So you should be able to just replace your top curve, and that'll recalculate the whole thing on the top. Once again, simple enough, right? Yay! I know, it's super exciting. So then here, now as you guys are getting caught up with me on that one, I'm going to begin to explain what happens with the other ones. So the other ones are a little bit different. If you notice here, the origin bias curve goes all the way to the end here at the base, and then it goes again all the way up here to the top at the bottom of that top chord. So sorry. Something to be aware of is that this extrusion actually went in the positive direction, not the negative direction. Okay, so that's why it's converging to a point on the bottom of the top rail or top chord. So if it matters to you, you're going to want to flip that down to the bottom side. If the outer profile of this is like your absolute maximum. Anyway, I just want you to be aware that that happens. So just for argument's sake, I'm going to flip that back to a negative so that it goes down instead. There you go. And so that's going to look like that now. And at this stage, I'm kind of looking at this, and I need to think about how I want the extrusion to look for this particular item. You have a few options. It kind of depends on how you want to detail it. I have the ability to extrude the face of this a little bit further out if I need to. I could also go through the process of actually trimming this curve. I could decide whether or not I want the internal curves to extrude both directions, but if I want my end curve to only extrude down, that's a possibility, but there will be some asymmetry associated with that. So for this case, let me check what scale options I have actually. Scale and non-uniform. It's going to give me the base plane X, Y, Z. Yeah, scale, that's what I wanted. Okay, so in this case, I think what I'm going to do is it's called, in Rhino at least, it's called scale one direction. And it just scales it along one axis. So for those of you who don't know, it basically means it's a stretch tool. So if I have a sphere, or a circle rather, if I have a circle and I scale it in the x-axis, it becomes an ellipse, right? Because I've stretched it out in one direction. So we can do that using the Scale NU tool. So it's under Transform, Affine, Scale NU. And so this is a scale with non-uniform factors. So that means if the y and the z remain at a scale factor of 1, and we change the x to be a scale factor of 2, then we've essentially stretched it in the x direction to be twice as wide. Does that make sense, theoretically? So let's apply it. Yeah, this is for the top chord. All right, so this is the item that we're going to extrude. Scale one direction. So we can plug that geometry in here. The base plane is kind of key. So the base plane is going to be something that we define to be the new x and y and z relating to the orientation of this particular item. So if I don't change the base plane and I use the world xy, that means that it's always going to stretch in this direction. So for instance, let me drop a param in here that scales it a value of 3, just for argument's sake so you can see what happens. So if I scale this 3 times in the x direction, it goes that way. And then if I change the orientation, then no longer am I in line, right? So we need to make sure that we reorient the plane to be associated with that particular edge. Also, the scale factor, you'll notice here when it's a world value of 3, it moves the geometry to this point right here. Or not this point, but I should say this position. So why do you think that is?
Cuts it into thirds.
What's that?
It cuts it into thirds.
No. Good thought, but no. It's actually really confusing because it's almost, actually it looks like it's exactly on that point. So I can see why you would draw that association. But the fact of the matter is, in the x direction, the position of the existing geometry is not on the x value of 0. So when it scales by a factor of 3, it takes the distance in the x direction that this thing starts, and it multiplies that by 3. So it starts it in a new position. So that means that the plane that it's scaling by is positional as well. It's not just orientation and direction, it has a position. So the plane is also the center point of scaling. Is that clear? So what we're going to do is find the midpoint of that geometry. Or whatever point we want to, scale it by. Or the midpoint of the line even would probably be best. And then we're going to scale it by that. So let me show you 2 ways of doing this. The midpoint of the geometry, which is the easy one. We just find the centroid. So let's go to Surface, Analysis, Area. And I plug this in. And then I plug the centroid into the p-value. So now you can see that it's extruding this geometry on both sides. Right, so that corrected it, sort of, kind of. However, if you... Oh, wait. Oh, it's only one direction, so it won't do... Okay, yeah, no, never mind. We can just use the centroid in this case. I was going to overcomplicate it, but... So anyway... in this particular position, we found the centroid. We basically replaced that as the plane. However, the centroid is not going to work for us here because, again, if I take this geometry and I move it, it's still an XYZ based point because all we did was give it a point, and the point borrows its orientation from the world XY in this case. So anyway, going back again, the actual way that we want to do this is to find our center plane / point by using a perpendicular frame. That's the best way that we can do this. So it's found under curve, analysis, perp frame. So the perp frame is evaluating a curve at a particular parameter. And so this is a domain. So it says parameter on curve domain to evaluate. So let's take a look at what that means. When I plug the, or basically I have to go back to the curve itself first. So I'm going to find the, where was it? There it is. Not top thickness. Top curve. And in fact, actually, I'm going to clean this up a little bit. So I'm going to do another wireless top curve. And I'll put this back over here. So the top curve gets plugged in. The parameter, right? So this parameter is saying that it's a parameter on a curve domain to evaluate. So when it says domain, I don't yet know whether or not it's a distance or if it's a percentage. So the reparameterize function might come in depending on what we want to do here. So I'm going to do a static number of 0.5 because I want this to be exactly halfway across the length of the curve. So I'll plug that in here. And what you see is that it places a frame halfway across the surface, or sorry, the curve. And if you get down really low here on it, you can see that it's aligned with the top of that rail. Are there any questions so far? Am I jumping too far ahead? Okay, so let's finish up this thought here. So the scale NU is going to require that we scale it in a particular direction that's relevant to the perpendicular frame. So when I plug the perp frame in as my plane, you'll see that the x direction is actually wrong. It goes down instead of out. And that's because now, if you look at the grid here, the x direction is this red axis. The y direction is the green. And then the z direction is the one that is now aligned with the rail itself. So it made a frame that was perpendicular to that line, which means that line then becomes the normal. Making sense? So this means our scale factor now needs to be on z and not on x. And obviously a scale factor of 3 is way too long. We probably just want to bump it up a little bit so that it encompasses the thickness of those arms. So I'm going to try something very, very small, like a 1.02. Okay, something like that should probably be appropriate, I'm guessing, for now. And I'll adjust it ever so slightly when I actually get the thickness of the arm on there if it doesn't look right. So what questions do you have?